Hey everybody, Dr. Burks here. So in the last video, Dr. C showed you how to make your graphs. So now you should know what the reaction order is in regards to the crystal violet. So remember, that is the M in our generic rate law. So we know M, you got that from your graphs. So now in steps 4, 5, and 6 of your calculations in the lab manual, we need to figure out what N is, and we need to figure out what K is. Right, so N, which is the reaction order of our hydroxide. So we're going to do that in step 4. We have this equation that we're going to use in our lab manual where N, which is what we're going to try to solve for, times the log of the first hydroxide concentration divided by the second hydroxide concentration equals the log of the rate 1 divided by rate 2. And rate 1 is just the rate of the first hydroxide concentration. Rate 2 is the rate of the second hydroxide concentration. So we need to kind of figure out what our rates are. We know the hydroxide concentration. Remember, we have 0.01 molar hydroxide and we have 0.02 molar hydroxide. Those are our two hydroxide concentrations. So we'll call this one number 1. The 0.02 molar, we'll call it number 2. So those are the concentrations. You'll just plug in 0.01 and 0.02. So that part's easy, we already know it. But now we need to get rate 1 and rate 2. So to calculate the rates, we have to then look at our data. So you're gonna go back to your data sheet, and what you're gonna do is you're gonna go for each of the concentrations, you're gonna have to do this calculation for each. So let's just look at the 0.01 molar first and see how to do that calculation, and then you'll do the same thing for the 0.02 molar. So we'll take 0.01 molar, you're going to go to your data sheet and look at two time points. We're going to pick time 0 and time 120 seconds. Right, so these are your times in seconds. So you'll go to time point 0, record what that absorbance is, right, whatever that concentration value is. I'm going to call that A1 because I don't know what your value is, right? But whatever it is, 0.4, 0.3, just record it. And then you'll go to the 120-second time point and do the same thing, record what that absorbance is. And then once you have those two values, then we can plug them into our rate expression. So remember, rate is just the change in concentration divided by the change in time. So our concentration here, we're using absorbance because it's related to the concentration, it's proportional to it. So your change is just your absorbance at 120, what I've called A2 here, minus your absorbance at time 0, what I've called A1. So you just plug your two values in there, and then you'll divide it by 120 seconds minus 0, since that's our change in time. And then you'll get some value here, and that is your rate 1. So that's your rate when the concentration is 0.01 molar for hydroxide. And then you're going to do the same exact calculation for the 0.02 molar hydroxide. You'll take your graph, again, use the same two time points. You'll have slightly different absorbances because you have different data there. And then you'll do the same type of calculation, and you'll get rate 2. So once you have rate 1, you'll plug rate 1 into your equation up here. You'll plug rate 2 into the equation up here. And remember, we know these hydroxide concentrations. This is 0.01, this is 0.02. So you just plug those in, and then you solve for N. And remember, N is your reaction order for hydroxide. So once you know N, you can go to step 5, where you're going to write out your rate expression, or your rate law. So you'll have your rate equals the rate constant K times the crystal violet concentration to the value M. Remember, you got that from your graphs, so you'll plug in what your value of M is equal to here. And then you'll have the hydroxide concentration. You just solved for N, so you're going to plug in up here. And your N value should be a positive whole integer. It should be 0, 1, 2, 3. And that's what you're going to plug in up here as N. So now we know M, we know N. We can then solve for what our rate constant K is, right? So we can use this expression. You can pick one of these rates. Actually, you have to do it for both of them. So you'll use rate 1, plug it in as the rate. That same value you have from your calculation here, plug it in as the rate. K is what you're going to solve for. And then you're going to plug in the crystal violet concentration, which, remember, that's a constant value from our lab manual. It's 1.6 times 10 to the negative 5th molar. You know the value of M, so you'll plug that in. The hydroxide concentration, if you're doing rate 1, it's 0.01 molar. If you're doing rate 2, it's 0.02 molar, just the appropriate concentration there. And then you'll plug in your value of N. All right, so you know all of these variables except for K. You can then solve for K, and you'll get your rate constant value. And then you'll also do that for then the 0.02 molar as well. So you're going to get two values for the rate constant, one from 0.01 molar, one from 0.02 molar. They should be fairly similar values. And then once you have your rate constant, be sure that you use the appropriate units for the rate constant depending on what the reaction order is. And then once you have that, that's basically the end of your calculations. So good luck.